Hey, Wagwan. Yeah, man, it's Mr. Garthreed here. We're going to be looking at a 2018 past paper question on stationary points, all right, from the May-June paper, the May-June 2018 paper for CSEC Additional Mathematics, all right? And we're focusing on section 3, which is Introductory Calculus. Okay, so the question says, given that y is equal to x cubed plus 2x squared minus 1, we are to determine part 1, the coordinates of the stationary points, part 2, the nature of each stationary point. Okay, so let us look at the solution for part 1. So part 1 solution. It says we are to find the coordinates, right? Determine the coordinates of the stationary points. Now, what do we know about stationary points? You should recall that stationary points exist whenever the derivative of the function is equal to 0. Okay? Remember that stationary points are also called critical points or turning points. Okay? All right. So it means that I'm going to have to find the derivative of y with respect to x. So we were given y is equal to x cubed plus 2x squared minus 1. All right, and I need to find dy by dx. So differentiating y with respect to x. So using the power rule, all right, you should remember that whenever we differentiate, so d by dx of x to the power of n, that is equal to n times x to the power of n minus 1. All right, so we carry down the power, 3, multiplied by x, and decrease the power by 1. So 3 minus 1, that is going to be 2. All right, plus, using the power rule here, carry down the 2 and multiply it by the 2 because 2 is a coefficient. All right, so 2 times the 2 will give us 4 times the x, and decrease the power by 1, so 2 minus 1 is 1. All right, you don't have to write the 1. And we know that whenever we differentiate, the d by dx of a constant k is equal to 0, right? So k is a real number here. So whenever we differentiate -1, all right, we must get 0. Okay, good. So we have our derivative of y with respect to x. All right. So remember that we're trying to find the stationary points now. So I'm going to make a statement here and say that stationary points exist when dy by dx is equal to 0. All right. So I'm now going to equate the derivative to 0 and find the x values. All right, so I can say that dy by dx is equal to 0 implies, we know that dy by dx is 3x squared. All right, we know that is 3x squared plus 4x, and we are setting that equal to 0. All right, so we're going to find the value of x. I recognize that x is a common factor in both of the terms. So when I factor out the x, I will have 3x plus 4 in brackets. All right, and that is equal to 0. So if you have x times 3x plus 4 equals 0, it means that either x is equal to 0 or 3x plus 4 equals 0. All right, so either x equals 0 or 3x plus 4 equals 0. So when 3x plus 4 is equal to 0 and I find the value of x, it means that x is going to be equal to -4 over 3. All right, carry the positive 4 to the right-hand side, you get a -4. So you have 3x equals -4, and then divide both sides of the equation by 3. You get x is equal to -4 over 3. Okay. These are the x coordinates of the stationary points. I now need the corresponding y coordinate. Okay, so I'm now going to substitute those x values into y here. All right, into y that we were given in the question. All right, it is a common mistake for students to substitute the x values into dy by dx. Please do not make that mistake, okay? So we know y is equal to x cubed plus 2x squared minus 1, and I'm going to substitute the values for x inside, okay? So I can now say when, all right, I can say when x is equal to 0, y is equal to, so substituting 0 in x into y, all right, substituting 0 into y as x, I will get 0 cubed plus 2 times 0 squared minus 1. All right, so just replacing x as 0 into y, and this is going to be equal to negative 1, okay? So that is the corresponding y value. So when x is equal to negative 4 over 3, y is going to be equal to negative 4 over 3 to the power of 3 plus 2 times negative 4 over 3 squared minus 1. All right, and if you should put that into your calculator, you will get 5 over 27. Okay, so I can now say that therefore the stationary points are when x is equal to 0, y is equal to negative 1, and negative 4 over 3, right? When x is equal to negative 4 over 3, y is equal to 5 over 27. Okay? And that is the solution for part 1 of the past paper question. All right, so part 1 is finished. We now need to do part 2, which says to determine the nature of each stationary point. Now, what do we mean by determine the nature? Well, it means that we are to determine whether the point is a local minimum or a local maximum point. All right, so local minimum point or local maximum point. Please do not put the term maximum point or the term minimum point, all right? Because we don't use those terms. We normally use the term local or relative maximum point or minimum point, okay? All right. I will explain further when we have calculated when we have determined the nature. All right, so part 2 solution. So when you determine the nature, when you are to determine the nature of the stationary point, we normally use different type of tests. All right, there are different tests that we can use. You can either use the gradient test, where you use the first derivative. All right, you use the first derivative, and based on this sign, so you substitute the x coordinates into the dy by dx, right? You will get 0, and you choose values to the left of the x values and to the right of the x values, all right? You pick a number that is close, very, very close to the x values, all right? And depending on the change of sign, that will determine whether you have a local minimum point or a local maximum point, all right? And you also have the second derivative test, where we calculate the second derivative, all right? And then we substitute the x coordinates inside, and based on the sign, whether it is positive, negative, or 0, we can determine the nature as well. All right, so I'm going to use the second derivative test here. So using the second derivative, all right, using the second derivative test. Okay, good. So remember that we had calculated dy by dx to be 3x squared plus 4x, right? That is what we have. So I need to find the second derivative, which is d2y by dx squared, all right? And we can write it as d by dx, sorry, of dy by dx, right? which means that you're differentiating dy by dx with respect to x. So this is equal to d by dx, and we know that dy by dx is 3x squared plus 4x, right? So using the power rule on this again, we bring down the power, multiply by the coefficient. So 3 times the 2 is 6 times the x, decrease the power by 1. So 2 minus 1 is 1. All right? Plus, we use the power rule on 4x, we get 4. All right? And that is the second derivative, d2y by dx squared. Okay. So now I'm going to substitute the x values inside of the second derivative. And based on the sign, we can determine what type of stationary point it is. Right? We can determine the nature, or we can classify what type it is. Okay, so when the first one we are calculating is x equals 0. So when x equals 0, we can say that d2y by dx squared is equal to 6 times 0 plus 4, which is equal to 4, right? And this value here, 4, is positive, okay? So we can now say that since d2y by dx squared at the point x equals 0 is positive, meaning that it is greater than 0, that implies that our stationary point 0, negative 1 is a local minimum point. Okay, now we use the term local or relative minimum point. All right, so we normally use the term local or relative. Do not put it is a minimum point, because actually this point is not the lowest point on the graph, right? That point is not actually the minimum point of the graph. Okay, so we normally use the term local or relative. Okay, I hope that was clear. So we know that 0, negative 1 is a local minimum point. How about when x is equal to negative 4/3? When x is equal to negative 4/3, we can say that d2y by dx squared is equal to 6 multiplied by negative 4/3 plus 4. All right, and that value is negative 4. Okay, now you recognize that this value is negative, meaning it is less than 0. So I can now say since d2y by dx squared at the point x is equal to negative 4/3 is negative, meaning it is less than 0, it implies that our stationary point, which is negative 4/3, 5/27, is a local, so you can use the term local or relative, maximum point. All right? And that is the solution for this past paper question. All right? So we have now finished part 2. Okay, so I hope this was very helpful for you. If it was, please ensure to like up this video, all right, and comment down below. Okay, I am Mr. Garth Reed, Student Ambassador in the University of Technology, Jamaica, and I'm also a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.